No. You're live now. Jaydev, you can announce.
Welcome back, folks. So we have Sandeep Reddy Malu back with us. He is standing in for his co-speaker, Steny, who couldn't join us because of some technical issues. His talk is on predicting COVID-19 case count, polynomial regression, and composite scoring. And over to you, Sandeep.
Thank you, Jaydev. When the COVID pandemic started, Graminer had partnered with John Hopkins arm in India, and we worked with the state of Maharashtra to assess the National Health Mission and their operators within each of the 34 districts to better plan for health infrastructure. One of the primary problems we were looking at was how do we build a COVID case count forecasting model. As a data science company, when we got into this engagement, we were looking at historic models of SAR models and the epidemiology-based models that are used conventionally to do pandemic spread forecasting. But given the unique nature of COVID-19 and the recency of the prevalence of it and lack of case level details in terms of understanding the pathology better, we were left with very few elements. There are only 4 elements available. It was a daily new case count, number of recovered, number of deceased, and number of active cases. This was the only information that the government was able to capture starting March 23rd onwards across the board in all the districts. Even the reporting within districts was not consistent. There were districts who were reporting once a week. There were districts who were reporting daily. Some were districts like Mumbai, Thane, and Raigad who had a large case folio count. The data was being updated on a rolling 4-hour window. So all these challenges had to be tackled. So when we attempted to look at epidemiology based models like SAR, which are conventionally the go-to models which were used for pandemic prediction for Zika and the likes of it in the last 2 decades, we were not able to get into any results that were closely matching the outcomes. So we took a different approach of how do you combine basic statistical approaches of taking time series data and combine some of the epidemiological information, actions, and interventions by the government on the ground and combine them together to arrive at a forecasting model that can at least help us in the direction of the case progression. So we made a couple of baseline assumptions because of the short-term nature of the data, the way each district manager, district magistrates, and health officers had to act upon it. We looked at focusing only on the cumulative case count as a metrics that we want to predict. And we looked at making a prediction model at every district level because Maharashtra as a state is north of close to 10 crore population, but the distribution of this population is heavily skewed towards the western part of the state for the 4 districts, and then corner in the Nagpur corner on the top and the Satara corner on the bottom. So we had to look at building models at a district level. So step 1 of the exercise was creating a creating a polynomial regression model that would take the data of X number of days from the data available, run a polynomial regression model for every degree starting from degree 2 all the way till degree 6 and look at which of the degrees output has the closest error and pick that nth degree for that particular district and arrive at the forecasting of the model. This was step 1. Step 2 was looking at any on-the-ground interventions that we were making with the government. Were there any actions from the government which essentially are lockdown, unlock incidents? What is the speed at which the testing was being ramped up? With the premise that when more testing is done, the number of cases would go up. And we also were closely tracking the test positivity rate for each of the districts wherever information was available. And the third metrics we were looking at essentially was to created a new statistical metrics called C19 Pro Score. What this parameter helped us achieve was using simple statistics. We were able to look at if you were to take last 7 days of case count, the absolute case count, the change in case count, the rate of change in case count, and normalize it against the population of that district. We were able to come up with a single score that essentially allowed us to look at all the 34 districts in the state of Maharashtra with a single view, so that the government was not only focusing on the districts with the highest caseload like Mumbai, Thane, Pune, but also look at the entire state holistically, so that the next potential hotspots or the next set of districts where the case counts were rapidly increasing, how do they intervene sooner? Because if you notice, for a government machinery to get a hospital set up, it at least takes anywhere between 7 to 14 days. So someone has to act upon it now so that the caseload coming in the next 2 weeks can be tackled. These are the kind of premises that we had made in and the assumptions that led us to take a composite forecasting model approach, where essentially the step 1 of the model was daily data being combined in Excel. We ran a data aggregator using a Python script, which would take all the daily information of all the districts, and take the last 7 days as a test data and the previous entire duration as a training data, and perform polynomial regression nth degree. That is data number 1. And this element of data is then multiplied by the different 4 factors that we talked about: the testing count increase or decrease, the C19 Pro score increase or decrease, and then the manual interventions by the government, which is that lockdown or unlock. We had found historic patterns. Let's say a lockdown would take effect 10 days from the time of when lockdown is announced. Similarly, an unlock event would actually have an increasing effect on the number of cases after the 4th, 5th, 6th day, depending on the population. Similarly, C19 score, when you see a jump in at least 30% on the C19 score, it's likely that the district will see higher growths. These are kind of different composite structures that we had brought in, which essentially allowed us to predict a cumulative case count for each district, that are 4 districts, and the forecast for all of these districts was added together to arrive at the Maharashtra's counts. Once this number was made available, we had to identify what is the infrastructure needs. So we looked at a proportion of new patients who are getting tested positive. X amount of them would be hospitalized. We took that number as 40% based on government's mandate. Government of India had these broad guidelines, which were from the Minister of Family, Health and Welfare. So we followed the same protocol. And once you had the 40% of the population needing hospitalizations, what is the type of breakdown for the kind of need? You need an isolation bed without oxygen, with oxygen, an ICU bed, and you had ventilators that you needed. So each of these essentially was the calculation that we ran using the Python programming language to automate this whole handshake. In addition, not just getting the number of beds that are required and comparing it against the number of beds occupied and then projecting how many beds each district would need for, we also use the same calculation to extend it to identify the number of PPE kits and the number of N95 masks that were required in different districts based on the projection of cases, based on the number of staff that are available on demand, and what is the number of kits required for each staff in a given shift. These are the different things that were combined together to create that forecasting model. This is how a representation of C19 Pro score would look like. On a particular given day, when you run this exercise and you identify that each district is scored uniquely using the C19 Pro score, so that you do not only focus on districts that have a numeric case count that is higher, but you focus on districts that have potential hotbeds. Like in this case, if you look at, this was a metric that was pulled on middle of end of July, where the districts that had the highest risk of case increase were Nagpur, Yavatmal, Ahmednagar, Nanded, Kolhapur, whereas districts like Aurangabad, which had higher case counts numerically, but they were on a lower trend, which means the number of case counts and the reduction was much promising. At a high level, if you look at the entire output of this composite forecasting model, essentially helped us to do 2 things very well. We were able to get to a near-term forecast of cases at a 14-day ahead. So if based on information that we have today, what is the potential likelihood of cases going on the 14th day? This was a primary goal we were chasing after. We were not looking at a longer horizon, given that these were polynomial regression based models, which have limited shelf life in terms of future ability. That was one. Second decision that we had made was, conventionally, if we were to look at 95% confidence interval for a forecasting exercise with a 2 standard deviation upper and lower threshold, that did not help us make any critical decisions. So after working with the epidemiology team in the NHM, we were able to agree on a threshold of 3 standard deviation both sides. Given that the nature of the problem, the involvement of reporting of data, which was manual, each of these helped us to combine with the forecasting exercise that is 3 standard deviations. After taking in all these parameters, we had an ability to also tweak the parameters, let's say the lockdown or unlock parameter, or the percentage of population that needs hospitalization, or the distribution of population. Each of these was configurable. That's where the ability to build quick an app on top of the Python script that we had created allowed us to tweak these values at a district level wherever required on a day-to-day rolling basis. This helped us to account for any on-the-ground options that were coming up. Let's say a district was reporting that we had cases like these, but we're seeing that the test positivity rate is going up or down. So we were able to adjust the model at a much granular district level. And all this output was made available on a web application that was built on using Graminer's low-code platform called Gramix, that gives you a series of components to quickly operationalize all the logic. And it also gave in a bunch of download options that would enable essentially each of the district managers to have access to a report on their district with past data, the projections, and help them to act upon it. This information was passed to them on every Monday so that they could plan for the next 2 weeks ahead. Coming on to the performance of this model, when we went back and compared the results in terms of the actual versus what we have projected, this is how the model performance has been. So in August, September, and October, we had a model performance that was north of 90% from an overall standpoint. This number is essentially the daily forecast for cumulative case count for each district for the entire month, and the number of times the forecast missed the 3 standard deviation mark versus the actual. That's how this metrics was calculated. Now, if essentially looking at this metrics, it was promising, but there were limitations to what the model has done. Given that it's a pure statistical model, we couldn't consider any epidemiological parameters like case, was there granular information of what kind of people were getting affected more, where is there a reproduction cycle, is there a gestation period that could account for. None of these were accounted in the model, so it doesn't withstand a test for a long-term forecasting. And also, the model's trend is, given the nature of polynomial regression, it is only as good as the trend of the last X number of days. We had taken a standard deviation calculation keeping in mind the last 7 days, and the robustness of the model was heavily skewed towards the recency of the data. So this again is essentially a limitation that we introduced when we had to get quick numbers out. And we also noticed a pattern where cases were approximately wavering in cases districts like, say, Gadchiroli, where the number of cases reported were less than 2 digits on most days. Model's ability to make a prediction was dismal. The accuracy of the model in those districts was less than 20%. And the last one was, given the short duration of which the data was there, which the reporting started in March, and by the time the pandemic had taken place, we had to act upon it. The recency of the data and the short duration essentially is not a good test case for making this model more robust. We definitely see a lot of possibilities where the model can be improved. Having access to patient data is one clear one. And if you can get a turnaround of the data capture, which is happening at a district level, that could help us understand the behavior much more granular way. And any of the parameters like interventions in terms of medical interventions that are happening, that was not factored into this model. So ability of government investing more time in rolling out apps like Arogya Setu or talking about preventions to take. None of it was influenced in the model. And the last one is the triangulation that we did essentially of the C19 Pro score and the model projections and different cross-sectional data. It also forces limitations, but it's also an opportunity to bring in more parameters into the overall solution. So this is what we have developed in the last 8 months. And the model took us a little over 3 months to refine. Starting end of July is when the model is operational. And the model has been used by NHM in Maharashtra for the last 5.5 months. And the model, I think, is running to the end of its life because the way case scores are growing in, it is not peaking as it used to be. So the efficacy of the model as well as the growth rate that we are seeing in the model is much on a lower clip right now. That's all for the talk today. Open to questions.
Thanks, Adeep. We are well in time for at least 2 or 3 questions.
Sure. I'm happy to answer questions. Could you read out the questions here there?
Yeah, I'm waiting for them. None yet.
Okay.
So Ankit is asking, do you assume that the incoming data is absolutely correct, or do you factor in error for unreported cases and so on?
Absolutely. The incoming data is only data which was passed through the government capture mechanism. So we had looked at that data as recency of the data has always been looked at as the most relevant one. So from a discounting factor standpoint, we looked at it as a 10% error rate in the data being reported versus actual. That was one of the factors we had considered.
I see. And so 10% was, where did that come from? Is that just an empirical figure, or?
This was the best case that we were able to get from the National Health Mission folks who are on the ground, who understand that the data generally takes a cycle of this much before it gets adjusted. So today, let's say district reports 10, tomorrow they come back and say 20 or 15, or they roll back, so no, it was wrong data. So we double counted patients, so they reduce the data. So this is their understanding of what we had taken as source of truth.
So my question, Sandeep, is if we had considered, or if we were to in the future consider data coming in from interventional sources, hospitals, Arogya Setu apps, or any other data, Would the model change, or would the same model be able to do better?
The polynomial regression model will still be the same, but the weights we assign to the composite elements, that would definitely change. So any new interventions that come in, they would have to fight for the weights between the composite scores.
Got it. Yeah. Shashidhar is asking, did you think of any other factors such as the density of population, people coming in and going out, etc.?
Yes, we did think about the possibility of including those, but then the place we got where we hit a roadblock was accuracy of any such data that is being made available. Anecdotal instances were available, but never certified data. And this information that we're building was for government to consume. So explainability of the model's behavior as well as explainability of the results was very important. Any factor that we couldn't explain clearly for the satisfaction of the medical officers, that was a criteria that we took. And these instances were where it was anecdotal, but not backed by real data, certified data.
All right. So there are no more questions. I think it's time to move on to the next talk. Thank you so much, Sandeep.
Thank you.
Thanks.
Bye.
So our next speaker is definitely a very interesting first at SciPy India. He's Sean Ray. Sean, you can start sharing your screen and your video. So Sean is a 8th grader from Texas, I'm given to understand. And he's going to be talking about Python as a first language. And we felt that it would be interesting to see this from the perspective of someone who's actually doing this as their first language. So thanks, Sean, for being with us. I hope this is not a terrible time for you. Where you are. Over to you. You can start. And please start sharing your screen.
Yes. So, good morning, good afternoon, good evening. I don't know where in the world you are, as this is an international conference. Yes, as the professor said, it is pretty early in the morning, but I am more excited than I am sleepy. So, as the professor said, my name is Sean, and I am an 8th grader, and I attend Salyards Middle School in Houston, Texas, in the United States. And today, I'll be talking about Python as a first language, as well as my personal experience and my perspective on it. So, looking at the outline, I'm going to start with an introduction. Then I'm going to talk about my motivation to learn Python. I'm going to talk about the reasons why Python was my first choice, my accomplishments, and then a summary. Okay, so an introduction. Python is preferred over 700 confirmed languages and 25,000 total programming languages. So with all these choices, which is the best to start with? And which programming language will give us the best chance of success, all while being easy to learn and interpret? Well, Python was created for the programmers, not just programs. See, a lot of languages have very good APIs and are very good at contacting with machines and bots, but lack on making it easy for programmers. Python, on the other hand, was created with the programmer in mind. In comparison to other programming languages, Python is a high-level language which has simple syntax, lesser memory consumption, more readability, and more object-orientedness. Now, Python, unlike competing languages, can be applied to many, many activities, such as graphical user interface building, system administration, cross-server, and more. And in this presentation, I will try to explicate why Python is the best, supported with evidence and experience. So, let's talk about my motivation. When I was deciding what programming language to learn, I realized that I could grow a lot with computer science. I realized the true potential that computer science had. Also, the recently begun digital millennium, also called the recently begun global digital era, runs on technology. Our present-day world runs on computers. I also learned that websites and applications of companies such as Facebook, Netflix, Instagram, Google, Dropbox, etc. run on Python. Instagram, in particular, has the world's largest deployment of the Django web framework, which is written entirely in Python. And the first Google engineers famously quoted, "We'll use Python where we can and C++ where we must." And along with that, I am required to take several programming courses throughout my middle and high school education. And if I want to develop a career in computer science, the time to begin is now, so I can have a head start. I also have to know programming for present education, future education, and to get opportunities later in life. So there's quite a few reasons why someone would pick Python as their first choice. And some of them are that it's open source, that the syntax is elegant, that it's accessible, and anyone can access it, and you don't need a super fast internet connection or things like that to access it. It's also simple, it's easy to use, and it was created for programmers, not programs, as we talked about earlier. It's easy to learn, it's easy to understand, it's user-friendly and has a good user interface, and you're less likely to get bugs and errors. Continuing, Python has a large and helpful community. In fact, the Python is the most popular language in the world, and there are a lot of people that are just there and willing to help you whenever you need it. There's also a lot of corporate support and demand because the corporate world needs programmers to run, and Python is a very powerful language, and they really, really want Python programmers, even preferring them over JavaScript programmers or Java programmers. Python also has hundreds of libraries and frameworks and extensions which you can add on to the base Python, making it even more powerful than it already is. Python is also versatile, reliable, efficient, and has a quick runtime. Python is also excellent at handling big data, machine learning, and as for cloud computing, well, the whole industry is controlled with Python. Python is also a very flexible language, and the use of Python for academic purposes is on the rise. And it is believed that Python will be the language taught for computer science courses very, very soon across the globe. Of course, Python is also very, very good for automation and is a renowned language in the field. So I believe that there are 5 criteria to make a good language for AI, machine learning, and deep learning. The first is, of course, that it's powerful and able to support big data without collapse. The second is that it must be a modern, up-to-date language, which will not suffer entropy for a long time, which basically just means that it will last for a very long time. And Python programmers can be sure that their code will last a long time. The third criteria is that the programming language must support extensions. And as we talked about earlier, Python has hundreds of libraries and frameworks and definitely meets this criteria. The fourth is that the language must have easy interaction with other languages. And Python has Jython, for example, which is its interaction with Java and many, many more. So Python passes this criteria as well. The fifth is that it has to have high levels of support globally. And Python, being the world's most popular language, also meets this criteria. So let's talk about how I ended up learning Python. In 2015, I started learning HTML, and HTML is a small language and based mainly on tags, so it was pretty easy to learn. In 2016, I decided to start learning a bigger language, so I started learning JavaScript. Then I realized how many languages there truly were, and also in 2016, I started learning PHP, Java, and Python, but got really confused on which one to actually begin with because there were so many different criteria to think of to make a good beginner language, and I wasn't sure. But in 2017, I was very, very sure that Python was best fit for me, and I'm very glad I made that decision. So let's talk about some of the accomplishments I have. The first is that I've been able to create educational resources, for example, a YouTube channel, and help nearly 20,000 others learn Python for both advanced learners and for beginners. And it's called Coding with Sean, as depicted here. Okay, so, of course, along with that, I've had a lot of personal accomplishments too, such as I've been able to do data analytics, I've been able to do statistical analytics, I've also been able to do tremendous amounts of mathematics, in particular arithmetic and calculus, and do this very quickly with Python, which would be very, very much so more difficult if you were trying to do it on paper. I've also been able to do data pre-processing and data processing, both of which can be very, very difficult and complex if you are trying to do it by hand. And I've also been able to make very aesthetically pleasing data visualizations with Python libraries such as Seaborn and matplotlib.pyplot. Of course, as we talked about earlier again, Python is a very strong language with automation. And I've been able to automate boring and repetitive procedures, making them not only very fast, but more accurate than they may be if someone was doing them by hand. And of course, by learning Python, I've gotten the opportunity to speak at this conference. Python has also enhanced my skill set in other ways. First of all, it has made learning other programming languages easier. Of course, learning any programming language or learning any one thing will make other things easier. For example, learning math will make learning algebra easier, and Python makes learning other languages easier. It's also increased my knowledge about data. As we all know, Python is a language that is very, very strong in data and has a lot to do with it. And with messing around with all these different data sets and, performing operations on so much data, it's naturally increased how much I know about data. Along with that, it's also enlarged my skill set with statistics. Statistics is a pretty complicated field, particularly the mathematical area of statistics. But when you do operations so quickly, it kind of gives you an idea of how powerful Python is. And it actually makes it easier to do it by hand because you can understand how it's being done so quickly and even put the algorithm in your brain and do it in a way like that. Along with that, it's enhanced my visualization skills. It really makes it so much easier to visualize something once you've seen it happen. And with Python libraries, you can visualize things to a very, very good extent. And with that, I've been able to make hand drawings that are much better and also more accurate and better for someone who has not previously seen the data. And of course, the times you do get errors, it can be frustrating, but it teaches you patience because the more you get agitated, the harder it is to fix those errors. And Python itself gets easier as more errors are resolved naturally because Python has a very complicated design internally, but that design gives you very, very precise, very, very accurate, and very specific errors. And so it's a lot easier to fix them. And every time you do fix them, it makes fixing errors in the future just a little bit easier. And slowly, fixing errors is much easier. So there's a lot of ways that I learned Python. First of all, my parents and siblings, although not computer scientists, use Python in their respective fields to a very large extent. So that is also part of my motivation, and that's why I choose Python. Along with that, of course, I've also studied the documentations, including Python's own documentation. I've read many, many books, all of which are at least very useful to some extent and allow you to see Python in text rather than simply on somebody else's screen. Along with that, I've also watched several videos and a lot of online tutorials, which can be very helpful because you can actually run the code in browser sometimes. And of course, since I have done some JavaScript, HTML, and PHP, the knowledge from those languages flows over. Just like the Python knowledge can flow over to other languages, it does the same when coming back. So there's also a reason that I created the educational resources. So when I was learning Python, I went through a lot of material. And despite thousands of different materials, both in the form of books, videos, and even online tutorials, I could not easily find any step-by-step, beginner-friendly, easy tutorials that make the language actually seem easy. They've made it seem complicated, and worse, they were aimed at higher grade students. And it was not good because I was a younger grade student, and some of the dialect and some of the ways that they did things were clearly not made to be beginner-friendly. And so I wanted to create resources which were very good at teaching even the youngest of students, because everybody, regardless of age, should be able to learn Python. The necessity of consistent creation of these resources also allowed me to be organized, dedicated, and even helped me learn to an extent. It also vitalized work ethic, and made me work hard, because to create all these resources, I had to work hard myself, both researching, running the code myself, and creating the actual tutorials. So let's talk about the future I could have. So it's great to be using Python and its libraries and its frameworks, but I want to go beyond being just a user. In the future, I want to contribute and give back, which anyone can do if they learn the language good enough. And it's very, very good if you can give back, because then you're not only taking, you're also giving back. And I also want to handle larger, possibly even immense amounts of data, all with Python and its libraries, and hopefully show people how much potential Python and its libraries have, as well as myself learn how to handle this data and hopefully become an expert with handling big data. Along with that, I want to identify the few weaknesses and gaps that Python does have and patch them, or better, even make them Python's strengths. Let's summarize. Firstly, we talked about why Python is a great language for beginners. It's user-friendly, it has a great user interface, it has a lot of libraries and extensions that make Python easier, and more. Python is also a top choice for advanced users because for the same reason, it has a lot of power and strength and qualities that make it good for advanced work. It's also very widely used, and demand for it is high because the corporate world is always wanting people who know programming languages which are commonly used, which are powerful, etc. And despite already being the most popular programming language in the world since 2019, Python's popularity is still rising as more and more people migrate to it, and of course, new people to programming are joining it. I myself have also been able to do a lot with it, such as create those educational resources, do data analytics, do statistical analytics, and more. And of course, try it out for yourself. If the language doesn't seem like a good fit for you, no problem, you can stop learning it. But it's definitely worth a try given all of the qualities that it has. So I'd also like to acknowledge my parents and Mr. Manikant Roy, who taught me data analytics, and statistical analytics to an extent. And at this point, I would like to thank you for your attention, and of course, a big thank you to SciPy India for giving me the opportunity to talk. And at this point, if there are any questions, I'll gladly take them.
Thanks a lot, Sean.
Thank you, Sean.
We have a good couple of minutes for questions. Let them flow.
Okay.
So I think there was one question which is by Dr. Shankar Rao, and he asked, are there any, what is the best book for Python is the first question, and then he says, what is a book on physics-oriented Python? There's been some discussion, but if you have a take on that, Sean, you can answer.
So there's a lot of books on those topics, and I would say the best answer to that is you've got to experiment out, because some books are better for some and some books are better for others, because it's really all about perspective and how the book talks. So I would say you should read just a little bit of every book and try to see which one is best for you.
That's a very wise answer. Yeah.
Thank you.
This is a very common question that for not just Python, but anything, like pick a technology and what's the best resource to learn that. Usually the answer is that there isn't one, because there's absolutely no lack of content. And one of the things that I guess I have learned to do very well is eliminate resources as quickly as possible. So if 30 minutes into a resource, whether it's a book or a tutorial or a video or blog, whatever it is, if it's not working out, drop it, pick something simpler, and then come back if it helps.
Yes, exactly.
So thanks again, Sean. Dr. Ajit says your talk is inspiring for students. Thanks again for being with us. Please hang around. If I guess if you're up already, if it's morning and you can hang around on the chat. We will have lightning talks now. So we'll stop this session at this point, and we will, in a few minutes, start our lightning session track. Thank you, everyone. And thanks, Sean. This was the last talk of the day. You did a great job.
Very much.